Hey, it's Mrs. Weethy, and in this lesson, we're going to talk about types of covalent bonds. We have two types of covalent bonds, the first being a nonpolar, which results in the equal sharing of electron. The reason for this is because the two bonding atoms have similar electronegativities. Remember that electronegativity is the ability to attract electrons. So since their electronegativities are similar, they're going to attract those electrons equally. The second type is a polar covalent bond, which results from unequal sharing of electrons because one of the bonding atoms is higher in electronegativity than the other, so it has a stronger attraction for electrons. If we take a look at the diagram we have here, bromine, which higher in electronegativity than hydrogen, so it's going to pull those electrons closer to it, resulting in a slightly negative charge on the bromine and a slightly positive charge on the hydrogen. This is what we call a dipole, and a dipole is opposite charges separated by a short distance, and that short distance is the chemical bond. Next, we have this diagram that just kind of shows you a picture of two different nonpolar covalent bonds between two hydrogens and two chlorines, and then what a polar covalent bond looks like between hydrogen and chlorine. When we look at two atoms that are forming a bond, we can determine the type of bond that they are forming by their differences in electronegativity. You have a table S, that has the ionization energies, the atomic radius, the electronegativity, and you need to get that out to do the next couple of problems that we're going to talk about. But if we look at two atoms forming a bond and their electronegativities, if we subtract their electronegativities and find that the difference is equal to 0, then the bond being formed between them would be a nonpolar covalent bond. If the difference is between 0 and 0.4, it would also be nonpolar. A difference between 0.4 and 1.7 would be a polar covalent bond, and between 1.7 and 4 is an ionic bond that would be formed. So let's take a look at an example of this. If we have a bond between hydrogen and oxygen, and hopefully by now you have your table out, well, look on your table and you will see that hydrogen's electronegativity is 2.2 and oxygen's is 3.4. Subtract those and the difference is 1.2. In our little table that I put down here, we'll see that 1.2 falls within a polar covalent bond. So stop the video, pause it right now, and do the next 3, and then come back and see if you got the same thing that I got. Okay, now that you're back, for carbon and hydrogen, we see that carbon has an electronegativity 2.6 and hydrogen is 2.2. That results in a difference of 0.4, making the bond between carbon and hydrogen nonpolar. Oxygen, because you have two oxygen atoms, they both are 3.4, so the difference is 0, and that's a nonpolar. And then sodium's is 0.9 and chlorine is 3.2, and the difference is 2.3, and that is an ionic bond formed between sodium and chlorine. Okay, so that is it for lesson 7. This is Mrs. Weethy. Goodbye for now.